In today's trig survival guide, we're going to verify a trig identity. So we'll look at tan of negative x times sine of negative x plus cosine of negative x equaling secant x. All right, so here we go. We know first we want to decide which side to work on. Usually we choose the more complex. So I think the left-hand side is going to be where we want to work in this case. Got a lot more going on, a lot more of a possibility for substitution and manipulation. So we'll go ahead and draw our vertical bar down from the equal sign. That way we aren't tempted to manipulate the right-hand side at all. And we should strategize. So I think we first may want to use some of our big trig identities. We're going to use the even and odd identities to make some substitutions to get rid of this negative x for each of our trig functions on the left-hand side, since we have a positive x on the right-hand side. So let's go through each one. We know that tangent of negative x is part of an odd identity. So we know that that can be replaced with negative tangent of positive x. And we're multiplying that times the sine of negative x. The replacement for that, it's also an odd identity. So we can replace that with negative sine of x. And cosine is an even identity. So we know that that cosine negative x can be replaced with a positive cosine positive x. And that all equals to our right-hand side, or secant x. So I've just abbreviated right side with rs. Of course, looking at this line, when we multiply two negatives together for that first term, that creates a positive. So let's go ahead and make that quick change here. And now we can assess what do we want to do next. So let's go ahead and rewrite tangent using the quotient identity. That way we can see a little bit more what we're working with in that first term. And then maybe we'll think about a common denominator, because we know we're trying to get these two terms connected by addition down to one single term. We're going for secant. So let's rewrite tangent as sine over cosine. And then that's being multiplied by sine x. And that's, of course, over 1. Or that whole term could rewrite to sine squared over cosine. And then we have plus just a cosine x. So that's like cosine over 1. All that's equal to our right side. So it does seem like a great idea to simplify this using the common denominator strategy. So let's take that second term and multiply by cosine x over cosine x. That gives us the common denominator we want of cosine without actually changing that term, because cosine over cosine is just multiplying by 1. So now as we move to the next line, let's go ahead and combine these two numerators since we have that common denominator. So simplifying sine times sine, let's write that as sine squared. And then we have plus cosine times cosine is cosine squared. We should be really happy seeing that. It's one of the most recognizable big trig identities. It's our Pythagorean identity, where sine squared plus cosine squared is 1. So that'll be a great substitution to make in a moment. We have all that over cosine x, and it should equal the right-hand side. So as we pause to assess here, we said the numerator here is a Pythagorean identity. We can substitute in 1 instead of sine squared plus cosine squared. And hopefully we see that will give us 1 over cosine, which then, using a reciprocal identity, that's just secant. So we are basically there. Make that replacement, show 1 over cosine x equals our right-hand side. And then there's the reciprocal identity. So secant x equals secant x. We have proved our trig identity. Check out the link in the video description if you'd like to see some more examples worked out for verifying trig identities. This is one of those skills that just takes a lot of practice. So the more problems you complete, the better you will be and the more prepared you will be for the next problem you work. So keep it up, and thanks for watching.